Hello everyone and welcome back to Clinical Cousins YouTube channel. Today we're going to go over how to quickly determine the patient's X, Y, and Z axis of the heart. So now if you haven't watched our previous videos on the electrical axis of the heart, then go and give those a quick view right now so that you can come back to this video and you can show off your knowledge, you can show off your skills, and you're going to have a little bit of fun while doing it, I promise. So to determine the X, Y, and Z axis of the heart, we need to remember to F DAT D. So your friend asks you, hey, how do you determine the X, Y, and Z axis so fast? You say, hey, you listen, you just got to F DAT D, and then please remember to explain exactly what you mean after that. So we're talking about EKGs here. We know that we have to find, determine, adjust, transition, and determine again. We already know that from our previous videos, but just to review, specifically we have to find the isoelectric lead, we have to determine the quadrant of the axis, we have to adjust the axis based on our isoelectric lead, then to find our Z-axis we have to use the transition zone, and we have to determine the quadrant again. Okay, so you've already mastered all these concepts, you've made it to this video, so what we're going to do right now is this. We're just going to run through an example where we put all of this together so that you can see just how much you learn. So here I've drawn for you a sample EKG. As you can see here, we have all the leads that go in the hexaxial system. So our XY plane, we remember that from previous videos. And I have our precordial, also known as our chest leads, our V leads, that are going to help us determine the Z axis of the heart. So we're going to hop right into it. Let's say you get an EKG, and first we have to find the isoelectric lead. So we give it a quick scan, we see that 1 is our isoelectric lead. Perfect. So next we need to determine the quadrant. So we look at lead 1, we see that it's more positive, so we know that this axis is leftward, and we look at lead AVF, we see that the QRS is also more positive, so it must be downward. So we know that leftward and downward means that we have a normal electrical axis. Again, this is just a general view, so we need to make it more specific. Next, we're going to adjust the axis based on the isoelectric lead. So we know that the isoelectric lead was 1, so that means we have our positive end over here, our negative end over here, and we know that the axis is going to be perpendicular to our lead 1. So we know that it's also in the normal quadrant, so this must be a positive 90 degrees. So we know that we need to adjust based on the QRS in our isoelectric lead. Our isoelectric lead was lead 1, and I know it's hard to see, but we're going to pretend that it is twice as positive as it is negative. So we know that our positive tug of war team was just a little bit stronger. So what we're going to do is we're going to adjust this to say that it is actually positive 70 degrees. So we know that our final XY axis is positive 70 degrees headed this way. We know that it's between negative 30 degrees and positive 90 degrees, so we know that this checks out, it's normal. So next we're going to use our transition zone. So we see that our transition zone is between V3 and V4. Therefore, we know that we have a Z-axis that is about 30 degrees. Again, it's between V3 and V4, so we know that it is about 30 degrees. Next, we already know that we determined that it's in the normal axis, which means that it's headed leftward, which means that it's posterior. So which one of these is it? We see that it is going to be 30 degrees posterior. We see that we have a final Z-axis of 30 degrees posterior, which we know is between the normal range of 20 and 40 degrees posterior. So we know that this is a normal X, Y, and Z axis. So that was a lot. But what did we just do overall? We found the isoelectric lead in lead 1. We determined that it was a normal axis. We adjusted, because the QRS was twice as tall, we adjusted towards the positive end of our lead 1. Then we used the transition zone to determine the Z-axis. And lastly, we determined the direction of the Z-axis based on the quadrant of our XY axis. So what is the result? We have a normal XY axis of positive 70 degrees and a normal posterior Z-axis of 30 degrees. So if I had to draw it, it would probably look something like this, right? That is probably the normal electrical vector if we had to put an image to it. So feel free to go show this off to your friends, and when you show them your skills on the EKG and you're going to say, wow, how did you determine that X, Y, and Z axis so fast? Remember, F DAT D. So as always, thank you for taking the time to learn with us today, and remember to like and subscribe if you're interested in viewing more of our helpful content. Thank you so much.